guys, welcome to Big Things Made Simple. In today's video, we're going to be talking about gram staining and what is it used for. So gram staining is used to classify bacteria into two groups according to the differences in the composition of their cell wall. So in the outcome of gram staining, there is two outcomes, gram positive and gram negative. In gram-positive, there is a thicker peptidoglycan cell wall, and there is an absence of the lipopolysaccharide protective layer. Whereas in gram-negative, there is a thinner peptidoglycan cell wall, and there is the presence of a lipopolysaccharide outer membrane. Peptidoglycan is also known as murin. The process of gram staining starts with using aseptic techniques to ensure that the experiment is sterile and non-contaminated. The first step is using an inoculating loop to smear bacteria on the center of the slide. Then, heat fix by passing the slide through a Bunsen burner. The next step is to flood the slide with crystal violet stain, which is usually purple in color. It will get absorbed by the gram-positive bacteria in the peptidoglycan cell wall, and in the gram-negative bacteria, it will be absorbed in the lipopolysaccharide layer. The next step is to rinse any excess crystal violet stain from the slide. The next step is by adding iodine. Iodine helps adhere the crystal violet stains to the peptidoglycan. It has no effect on the gram-negative bacteria, but it does have an effect on the gram-positive bacteria. Next is to rinse any excess iodine from the slide. The fifth stage is to add a decolorizer, which is usually ethanol. Ethanol is used to dissolve lipids or the lipopolysaccharide, but in the gram-positive bacteria, where it does not have any lipopolysaccharide layer, it does not have any effect. But it does have an effect on gram-negative bacteria. Alcohol will dissolve the lipopolysaccharide layer, which is made of lipids, and will simultaneously wash and dissolve away the crystal violet stain, leaving the gram-negative bacteria to be made of only the peptidoglycan outer layer, without any stains. This is a diagram that shows the gram-negative bacteria after the outer lipopolysaccharide layer is dissolved by ethanol. Rinsing occurs after every stage to ensure that there is no excess solution left on the slide. The third and final stage is to add safranin, which is a counterstain commonly red to the slide. In gram-positive bacteria, there is no more space in the peptidoglycan layer to absorb and retain the counterstain because all the space has been taken by the crystal violet stain, so it does not have any effect on the gram-positive bacteria. However, in a gram-negative bacteria, the newly exposed peptidoglycan layer, which has not absorbed or retained the crystal violet stain, will now absorb and retain the counterstain, safranin, and therefore it will come out as red under the microscope. So to summarize, after rinsing in the final stage, the final outcome will involve gram-positive bacteria being purple under the microscope due to crystal violet stain, and gram-negative bacteria being red under the microscope due to safranin, the counter stain. The gram-negative bacteria will not look purple because the crystal violet stain, along with the lipopolysaccharide layer, was dissolved and washed away by ethanol. Thank you guys for watching, and please make sure to leave any topics that you want discussed under the comments below. Thank you.